Hello again. We are continuing our discussion by talking about how to simplify radicals. So let's get started. Whenever you need to simplify a radical, you need to be familiar with the process of prime factorization. And the first method that we're going to talk about to do that is the tree method. Now here's how it works. You're going to be given a number, and if you can, you're going to split that into two factors, and you're going to use branches for each of the factors. And for each new factor that you create, you're either going to circle it if it's prime and can't be factored anymore, or you're going to split the number into two factors if it can be factored. And you're going to use two more branches for those factors. And you're going to repeat this process until all the factors at the ends of the branches are prime. So let's go over that process with the number 3060. I know that 3060 can be divided into 306 times 10. And now let's look at the 306. That can be factored into 9 times 34. And let's focus on the 9 and the 34. 9 can be factored into 3 times 3. Now each of those 3's is prime, so I'm going to circle it, meaning that I'm done with those branches of the tree. Now looking at the 34, that can be factored into 2 times 17. Both of those are prime, so I can circle those. So now I'm ready to look over at the 10 over on the right-hand side. 10 can be factored into 5 times 2. Each of those numbers is prime, so I can circle each of those. And now that everything at the end of the branches is circled, that means I have finished with the prime factorization, and I just write the numbers in order from least to greatest with multiplication signs in between. So I know that 3060 is actually 2 times 2 times 3 times 3 times 5 times 17. I'm going to use the same number, but do a different method. This is called the division method. So what we're going to do is we're going to take that number, 3060, and if it's possible to divide it by 2 without any decimal or without any remainder, I'm going to do that. It is possible to divide 3060 by 2, and the answer is 1530. If I can divide by 2 again, I'm going to do that again. And that is possible, so I will get 1,530 divided by 2 is actually 765. Now looking at 765, that is not divisible by 2, so I will go to the next number, which is 3, and I'm going to divide it by 3. 765 is divisible by 3, and the answer is 255. Can it be divided by 3 again? Yes, it can, and the answer is 85. But 85 is no longer divisible by 3, so I move to the next prime number, which is 5. 85 divided by 5 is 17. The next prime number after that would be 7, but 17 can't be divided by 7. I keep going through the prime numbers until I find one that works. 17 can be divided by 17, and the answer is 1. Now once I get a final answer of 1, that means I've finished dividing. And if I just look down the column of what I was dividing by, that is my prime factorization. So again, 3060 is equal to 2 times 2 times 3 times 3 times 5 times 17. So those are two methods for finding the unique prime factorization of a number. I'm going to need that in order to simplify radicals, and here's why. If I wanted to find or simplify the square root of 3060, I need to know what the prime factorization is. And I found it twice, so it's 2 times 2 times 3 times 3 times 5 times 17. So here's how I'm going to simplify the square root of 3060. Any pair of equal factors is going to be written outside the radical sign. So the pair of 2's gets written outside as a single 2, and the pair of 3's gets written outside as a single 3. And then anything that is left as a single factor is going to get left inside the radical sign. So the 5 stays inside and the 17 stays inside. So the square root of 3060 is 2 times 3 times the square root of whatever 5 times 17 is. And obviously both of those can be simplified, but they have to be simplified separately. So the 2 times 3 can be written as 6, and 5 times 17 can be written as 85. So the square root of 3060 can be simplified to 6 root 85. All right, and here's another example just to work with a different number. Let's say I want to simplify the square root of 2100. Well, first I need to find the prime factorization, and I'm going to use the division method again. 2100 can be divided by 2, and the answer is 1050. That can be divided by 2, and the answer is 525. But that can't be divided by 2 anymore. So I'll divide it by 3. 525 divided by 3 is 175. That can be divided by 5. 175 divided by 5 is 35. That can be divided by 5 again, and the answer is 7. And that can be divided by 7, and the answer is 1. So once I get to 1, I know that I've finished with the prime factorization, and there it is right there. So 2,100 is actually 2 times 2 times 3 times 5 times 5 times 7. So remember, what we do is we write the pairs outside the radical sign, each as a single number. So the 2 times 2 comes out as a single 2. 5 times 5 comes out as a single 5. And then anything that was not paired up can stay on the inside. So the 3 stays inside and the 7 stays inside. And then I simplify the insides and outsides separately. So my final answer is going to be 10 root 21. So the square root of 2,100 can be simplified to 10 root 21. So that is simplifying radicals. If you have any questions, please let me know, and I will see you tomorrow.